It works. Alright, hey guys, I'm back with another video. Hope everything's going well for you guys during this break from school that we continue to have. Today I want to talk to you guys about electricity and how electricity is generated. And so we've learned about this quite a while ago, but we know that electricity, we've got like a copper wire, and the electrons inside of this wire are the things that move to give us electricity. And so we have alternating current and we have direct current. Those are two different types of electricity that we can get. And alternating currents, these electrons, they move back and forth in the wire. And that's what we see out on power cables outside of our house, along the highways. Those have alternating currents inside of them that's always constantly moving electrons back and forth and giving giving electricity to wherever those power lines are running. And we also have direct current, which in that case it's like creating a circuit, and that has electrons flowing through it inside of a circle constantly. So that's a direct current in a circle. So a cool thing that people figured out a long time ago is with magnets, putting it next to this wire, magnets can either have a positive or a negative charge. And when they put the negative charge next to this wire, it would affect the electrons just like a pulse of electricity would. So if you run a negative wire or a negative magnet by this wire, it's going to push those negative electrons one way. And then when you pull it back, those electrons come back. So a magnet can have the same effect with a wire as a alternating current does. So I talked about how a negative end of a magnet can have a pulse of electricity go through copper wire. Well, the positive can too. The positive is going to pull those negative electrons to it, and then when you pull the magnet away, the electrons are going to go back to where they were. So either one, a negative or a positive charge on a magnet, is going to have a pulse of electricity move through the copper wire. So what that means is you can have a roll of copper wire, and you can have a battery, and you can have a simple magnet on top. And the battery will create a direct current that will run through this copper wire. And at the same time, every time this coil of wire passes by this magnet, it's going to push electrons through the copper wire just like the battery is pushing it through. And the effect is, we got this cool, we gotta keep going. We got this cool electric motor that will continually run as long as the battery has a charge. So, kind of cool. It's alive. Still going. So what that means is, if you have something like water or wind or something that's continually flowing, if you can use that water to spin a turbine, inside of the turbine you can have, say, a bunch of, oh man, my marker is not working. Say a bunch of magnets. So you've got inside of this turbine a bunch of magnets, and then on the outside of the turbine, that's where you put all your copper wire. And so you run all this wire all the way around, and you run it out so that every time a magnet is passing by the copper wire, it's providing that jolt of electrons back and forth. So you got these huge wires coming off these turbines that are constantly spinning, and you've got AC current happening and pushing out electricity through that wire. So you run those wires to whatever you want to power, like your home, run it to a school, whatever it is, and as long as this is spinning, as long as the turbine is spinning, again, through water power, through air power, whatever it is you got, you're generating electricity. Alright, so let's talk about how a coal power plant works now. This is a picture of one online. Hopefully you can see it well. I'm not going to try and draw it out. So you've got your coal supply here, and the coal gets pumped into the boiler furnace room, and it'll get super hot in here, and you run this water through pipes, and it gets heated up, gets pressurized. It pushes that steam, that pressure through pipes over here to spin the turbine. Turbines are connected to the magnets with a copper wire. Copper wire pushes out the electricity through the transmission lines. And pretty simple process, but the bad part is when the coal gets burned in this room, you can see the fumes. They come out these huge smokestacks. It creates a lot of carbon dioxide. Creates a lot of electricity, but a lot of carbon dioxide, which is a greenhouse gas, which helps contribute to global warming. Okay, so a couple years ago, I was able to find a video on YouTube of a redneck engineer guy. I'm pretty sure he's from Alabama or somewhere back there. But he was able to make his own hydroelectric generator using the stream in his backyard. And he used that to power like some refrigerators and some other things in his garage. But anyway, super cool video. Further shows and explains how he built the hydroelectric generator and how it generates electricity. So go ahead and watch that now. It's included in this same email. Give that a watch, and again, be thinking about how we can use these ideas to come up with our own idea to cut back the emissions of carbon dioxide. How can we produce less carbon dioxide so that we can be better off in our world? It's still going. Still going. I should submit this to Energizer batteries. This could be like a commercial.